Yo, what's up, SciFam? We're back to part 2 of the climate controls. So as you know, the following factors control regional climate, and climate is what controls ecology, or what types of climates we have on the ground of the Earth. So latitude impacts our climates, the latitude where you are on the Earth. The atmospheric circulation, the air above your head, affects your climate of where you're located. And the current elevation that you're at also impacts the climate, and climate impacts ecology. So let's keep going here. So part 2, well, this is now the beginning of part 2. Here we go. Number 4. Number 4 is your proximity to a large body of water. Proximity to a large body of water. Okay, so we need to explain this so you can see that we're going to write a few things before we really jump into understanding how this works. Let me draw a line here to help bring the attention away from that little title thing. Okay, proximity to a large body of water. Now, let's dig in. Large bodies of water are going to add moisture. Because you have a lot of water near you, then it's easier for there to be water in the atmosphere. So they add moisture to the air, and they end up increasing, and increase is the word here that I need to add, and increase chances of precipitation. Remember, precipitation is anything like rain, sleet, snow, anything that is wet that falls from the sky is precipitation. So if you are close, proximity means how close are you to a large body of water. If you're close, well, large bodies of water add moisture to the air and they increase chances of precipitation. So we can also not only look at how much water is in the air, the humidity or the amount of precipitation, but we can also look at air temperature. And if you live near a warm body of water that's really large, warm bodies of water are going to add heat to the air. If you've ever been near a hot tub in wintertime, you see that the heat from the hot tub actually goes above the hot tub, and you can see the steam there. That steam is that the hot tub's trying to heat up the air. Well, if you have a huge body of water, it will heat up the air. And the same thing is true for a cold body of water. If you're near a really cold body of water, it's going to take heat. It's going to rob the heat from the air. So therefore, it's going to feel colder. So if you're near cold water, it's going to feel colder, and if you're near hot water, it's going to feel hotter. So in order to explain that, we can take a look at the ocean conveyor belt. This diagram was produced by Columbia University, and you can see this area that we're going to zoom into right here. Now, you can see that the hot water kind of goes across the surface. It gets warmed up here in the equator. It then goes up to the north. As it goes to the pole, it sinks because it gets colder. It then stays along the bottom as it travels through the South Pole. As it goes back up, it starts to warm as it rises up in this region, and then we end up with warm water that continues to get warmed at the equator. Right now, though, let's focus in on this location right here. So we have hot water coming up right next to Portugal and Spain. So that's our example here. So go ahead and you can draw yourself a little version of Portugal and Spain, and all we need to show is that we have hot water that's coming up from the north. It then turns into cold water way up over here, and it descends down. So what this means then is that we end up having, well, let's write here that we have warm water, and what that does then is we end up with a warmer climate than it would be if that warm water wasn't there. And I can prove that because if we look down here at this map, Spain and Portugal, if we look at where they're at here on the Earth, these areas should have climates that are similar to New York, Connecticut, Massachusetts, Maine, but it doesn't. It has more of a nice, beautiful, warm climate. These areas over here in the northeastern United States can be really cold and frigid. They have crazy, crazy winter times. Here in Spain and Portugal, they don't quite experience that because they have this warm ocean water that travels by them, and it warms this climate. Now, another example that I want to use in order to show how large bodies of water add moisture to the air and increase the amount of precipitation? Well, let's jump over to the Great Lakes region. This is the state of Michigan, and the weather for Michigan comes usually across this lake. This is Lake Michigan. So there's a large body of water here. And what this large body of water does, I need to get out the white, because what it does is as soon as, all this air travels across the lake and picks up moisture, and when it hits the land, the air rises up because the land is warmer. So that air rises up, and all of a sudden, immediately, it starts creating clouds. And so if you've ever lived in Michigan or been to Michigan in wintertime, a lot of wintertime is Michigan covered in clouds. It's very common for there to be a complete blanket of clouds over Michigan. Not only that, but there's more moisture over here on the west side of the state, and the west side of the state actually experiences more precipitation as well, especially during snowstorms. When it snows in Michigan, this region here in the west side of Michigan gets way more snow. This side gets a little bit less snow, and over here gets an average amount of snow. Over here on the east side, they don't get as much of that snow because they're further away from this large body of water. So this large body of water is adding a lot of moisture to the west coast of Michigan, which is causing there to be a lot of snow in the wintertime and a lot of rain in the summertime. So that's how a large body of water can affect the climate of a region. So we're not looking at this whole place, we're just looking at little parts of these places. All right. So if we take a look here at a map, you can see that there are deserts in some regions, but in some regions where there maybe should be deserts, like here in India, there's not. Here in the United States, we have some deserts that form, but there also should be some deserts here, and there's not, and that's because of mountains. So not only do we have to think about where the water, these large bodies of water are, and large bodies of water are ones that we can see here on this large map, things from space, large bodies of water, like the oceans, Great Lakes, things like that. But not only do we have to think about the large bodies of water, but we also need to know how close are you, your proximity to mountains. So proximity means just how close you are to something. Okay, so let's look at what happens here. Well, mountains force air to rise. It forces it. If air wanted to come through this region, it can't go through the mountain. It's forced up and over the mountain if it wants to get past the mountain, which the air does. It has to move past the mountain because it's in motion. So mountains force that air to rise as it passes over. As air is forced to rise, it causes there to be more clouds. That's because this air is warm down here, and as it rises up, it gets cold, and when it gets cold, it starts to form clouds. So not only is there cloud formation, but there's also going to be precipitation. So let me reread this so we can get the sentence structure correct. As air is forced to rise, it causes cloud formation and precipitation on one side of the range, the mountain range. And we get a dry rain shadow. So think about a shadow. Well, a rain shadow is just meaning that all the rain is gone and there's no rain at all. So a dry rain shadow on the other side. So what we should see then in this example is if we draw this mountain, go ahead and draw yourself a line on your paper to draw the mountain. On this left side, we're going to have air coming in. This air is coming in, and it doesn't know the mountains are there, but it's about to hit the mountains. When it hits the mountains, it started to be forced up the mountains and over the mountains. But what we find then is that we end up with cloud formation. So here, there's not a lot of force of that air being pushed up yet, but as it gets pushed up more and more, we get more and more puffy clouds, we get more cloud formation. And the higher up you go in elevation, if you've ever been able to go up in higher elevations, you know that we end up getting a lot more precipitation up here in the form of rain in the summertime and snow in the wintertime at high elevation. And that's because this air is forced up over the mountains. Now what happens is that now that all that water has been sucked out of that air, when you come down this downside, we end up having dry air descending. And so this side on the right side ends up being a rain shadow. And a lot of times we end up with deserts. A lot of times deserts are on the other sides of mountain ranges, where on one side it's nice and there's a lot of trees and vegetation over here. And on the opposite side, there's a lot more cactus that form because this is more of a dry type of landscape. It doesn't have to be hot, but sometimes they are. Sometimes they're warm. So let's fill out what we've got here on the left side. We have cloud formation and precipitation, meaning that we have clouds and rain, clouds and snow. This ends up creating a wet climate. And on the other side, we have a rain shadow, which is a dry climate. So a good example of this is if this mountain range that I drew were the Rocky Mountains here in Colorado. The west slope, the air comes up over the west slope. The Rocky Mountains in the middle of our mountain range, this is where all the ski resorts are. This is where all the snow falls in the wintertime. But if you come down to Denver region or where we live in Fort Collins, this area is actually called a desert. And we call it a steppe is the more correct term for the type of desert that we're in. But we are in a desert region because all of the moisture gets sucked out of the clouds as they cross over the Rockies. But what that means is we get lucky enough to have like 300 days of sun each year, or even more than that, probably like 340 days or something of sun each year. And also, we don't get the type of snow down here in the Front Range that they do up in the mountains. And the reason is because we actually are in the rain shadow of the Rocky Mountains. Well, there you have it. There's 5 factors that you need to consider when looking at the climate of a region, a small location on the earth. So the proximity, how close are you to mountains? How close are you to a large body of water? What's your elevation? What type of atmospheric circulation is above the earth at your latitude? And what is your latitude? Because we need to know the sun angle to determine the temperature. And now you know the 5 things that control climates.